All right. Hello. Attention. Quiet down a little bit, please. Uh, I appreciate everyone chatting with each other, actually. It's nice to have some, life and conversations in the room. Uh, for those of you that don't know me, I am Tyler, but I go by Corby, so you'll see me as that on the Discord, and also that's what people will call me usually. People being the officers who already know me, or just any of you that already know me. But I go by both. So welcome to Game Devs Organization. I am the treasurer. This is our president, if you want to introduce yourself.
I believe I, I'm on board, so start some duty. And if you're learning game dev and you have like a problem when you're coding or something, you can always DM me. I'm always open to like call and help you through problems. Anybody who's learning, who's new, I'm always here to help teach or help get through whatever problem you're having. Just want to make that note.
And there's also the programming tab in the Discord, server. There's programming. You can ask any questions down here if you want for like game development programming stuff. Yeah, or just asking some other ones.
Camera's here, top of the monitor.
Oh yeah.
No, you're not being recorded. Don't worry about it. Yeah. And also the person who just talked, this is Just. He is our vice president. So he'll be giving the presentation today on Godot. Speaking of, if you have not seen the announcement or you just didn't know, you can follow along with this presentation. There are interactive bits. I see a lot of you already have your laptops. There is a link in the Discord in announcements to install Godot. So you can go ahead and grab that. And I believe within the presentation, there's instructions on how to install it, right? Is that true?
Oh yeah, I have a link in the Discord announcements.
Doing something you can finish, but it seems like the gain on the mic is just making it so that it's quiet and like most of your words are not coming through at all.
Okay.
I think that's a Discord issue.
Maybe I'll just
Yeah,
like
I
speak
think
directly
this
into
as
the
well.
microphone and see what happens.
Because it's go ahead and talk. I have
Okay, yeah, can you hear it properly like this? Can you like hear when I talk like that? Oh. Yeah. It's basically ice cream cone.
All right. Look, a couple more things before we get started, just to talk about general club stuff. Again, since a lot of you are new. So next week, we're going to be starting our month-long game jam. Essentially, we're going to have the next 4 meetings dedicated to kind of helping you generally through the steps of that. Like next week is going to be talking about how to determine your scope. If you haven't actually programmed something before, like what engine is good to use. If you're not a programmer and you're here for more art, music stuff, we're hoping to be able to help you guys form groups for those of you that want to be in a group. Otherwise, of course, there's the Discord to be like, I have this idea, I'm making this, and I need a artist, I need a whatever. So there's going to be that. So look forward to starting with that. But today we're going to learn how to use Godot, which is an engine that is probably the least known, or at least known how to use. I don't know how to use it, so I'm going to learn today as well. But I'm going to hand it over to Just. So you take over.
All right, hello everybody. Let's see. Is the sound working? It's not glowing here. Usually on Discord it glows. All right, so yeah, I don't know. Can you hear anything through there?
Not right now, but I'm
Yeah, I'm not sure. All right, let's just get started anyway. Actually, Corby, I guess you could. No. Nah, okay. Godot, making a game. So, oh, whoops, I did not highlight it here. Making a game in Godot. My name is Jus, rhymes with bus, gus, or sus. Here's how to make a game in Godot. So, why Godot? Well, it may not be the most widely used in the industry, but there are lots of universal game development concepts and like software, real-time software concepts in general. Like there's scenes, delta, lerp, shaders, export bugs, etc. And Godot is small. Like, it's really fast to download. We tried this whole sort of tutorial thing with Unity once. Most of it was spent downloading. So you can see GameMaker is about 4.86 Godots. Unity is 80 Godots. And Unreal is 172 Godots. It used to be 250, but they recently optimized it. It's like 10 gigabytes less than it used to be. And then it's also free and open source. Here's the GitHub URL. that means that you can take the source code, you can modify it, you can upload your modified source code anywhere, and you're legally allowed to do that. So yeah. And also, Godot is the engine I'm most familiar with. So keep in mind, I may throw some shade at Unity here and there. That's because I'm mildly familiar with that engine. I've used it a couple of times. So what do I expect you to know coming into this presentation? Nothing. I'm introducing everything from scratch. You don't have to come in here with any knowledge of anything. So yeah, how Godot? Make sure to download it. Here it is, download for Windows. I have the link in the Discord here. And also make sure that you don't get the .NET version. That uses a different programming language, and I'm not making two versions of this tutorial. So I'm just going to use the regular standard Godot engine here. So let's see. Does everyone have Godot now? Like everyone has downloaded it? Yeah, I guess that means we will proceed. So I guess moving on. Oh, I was going to do table of contents. I didn't have time. Sorry. Now to start. Now to start off, big picture. Download my assets, make a new folder, create a new project in that folder, and select the proper settings. So that's what we're going to be doing for this chapter. So download my assets. I made a bunch of assets to use. You can, here's the link here. I also sent the link in the announcements in the Discord server. So all you have to do is download it. You can see you have to click the code button and click the download zip button. These are just going to be some images we can use. We are still going to be covering how to start up a project from the beginning. It's just like pictures here. So you can see I clicked the code, download zip. And now you can see me installing this live. So let's see, you guys can download this. So what we're going to have to do now is create a directory. This is just going to be a folder because if we make a bunch of games, we don't want them to just be loose somewhere. You can just make a folder and just stick them in there. So open up your File Explorer or Finder or whatever else you guys use on Linux, and go somewhere like your Documents folder and create a new folder for Godot games. So you can see here, I am going to just open this up. I'll create a new tab. Whoa, fancy, Windows 11. So Documents, New, Godot. So I'll just be making games in here. All right. Everybody caught up and made a folder. So now we will start off. Wait, I thought I made something here for like how to install Godot. Oh, wait, no, here it was. Oh, yeah, I skipped it here. Unzip and run. So to unzip it, let's go into the downloads here. You can see I downloaded Godot. Just click and drag this out into the downloads folder. And then Windows knows you want to unzip it from the zip file. So here you have the program. Look at this. It's loading on the other screen. Here it is. Godot, we installed it. Huzzah. And now here are my assets that I made. Here's how to set those up. So over here, I will go to the Documents folder, the new Godot folder, and I'll actually first create a new project as the slides show. Maybe this is going to be a bit cumbersome with the slides and doing this. But yeah, you name the project, you browse the folder, use the compatibility renderer, and version control is optional. You don't have to worry about that. And make sure you check the Edit Now button. So you can see here's Godot. I'll name this Platformer. Ooh. And it will be in the Godot folder. Use the compatibility renderer. And yeah, and then you can click the Create button once you're done with that. And now It's loading in the other screen. Yeah. Yeah. Okay, yeah. Sorry about that, guys. So here's Godot. We've created our project. You can see here's the editor. You can get familiar with that for now. How many of you have made it to this step now? Show of hands. Oh, sometimes if you accidentally press the uncheck one of the little boxes, it doesn't open up properly. But yeah, now it's open. All right, I see this as an absolute win now. So you can see here's our editor. Familiarize yourself with the environment here. So you can see there's a little summary of things. There's a menu bar and workspace, play and pause for when you want to test out your game, the inspector for if you want to inspect anything you've selected in the scene viewport, the scene hierarchy, the objects in the current scene. I'll explain what these are later, and the file system, which is just a file explorer. And put my assets into here, into the folder. So, yes, let's just do that quickly. I'll show you how to do that. Here's the folder, and here are my downloads somewhere. So here are my assets that I made, and then I'll just drag all of these, open this up. So you see the folder with the .godot in it. You drag all of these into here. And then if you notice afterwards in Godot, you'll see all of the files in the file explorer. You can see the art. Look, here's a player. Look at this guy. Okay, so moving on, let's just take a quick look at other game engines just so that just in case you don't trust me about the universality thing. Look, here's Godot. You can see I have the menu bar in red, play button in green, main viewport in yellow, hierarchy in blue, stuff like that. You can see it's basically in Unity, it's the same, but the play button is over here, and the file system is across the bottom. And then here's Game Maker. By default, the asset browser is the file window on the right. The inspector is on the left by default. You can move in most game engines, you can just move anything around anywhere, but here's the default positions for all of these. And then here's Unreal, where there's the viewport over here, the play button in here, the menu bar up here, the outliner as it's called here, content browser. So anyway, I keep talking about these scenes, but what are scenes? Well, yeah, universal concept. It's a workspace where you place everything in a particular section of your game. I asked people on the Discord to explain a bit better. A scene is a bucket where you stick all the stuff that makes up a piece of your game. So in Godot, it's even simpler than other engines. You see, a scene is a container for nodes. Nodes are the things that make up your game. The magic part is that any scene can be used as a node in another scene. So as for what nodes are, most other engines just call them objects or actors. That's probably more intuitive, but Godot calls them nodes. So they're nodes. And if you're used to other engines, Corby, it's not as confusing as it sounds. Effectively, all it means is editing a prefab is exactly the same as editing a scene. So, editing, editor settings. Before we get started, the game engine is going to make some assumptions about what we want to do. We'll just correct it on a few things. We're just going to change the resolution and texture filtering. A rough time estimate, 5 minutes. So, Godot likes the default resolution at this weird, awkward thing. It's multiple of a power of 2, but let's just modify that. Let's make it 720p, one of the standard resolutions. So project settings. And then we go to, let's see, I forgot. The window. You can actually search here. Oh, viewport height. It's viewport height and view. Yeah. So here, window, viewport width, and viewport height. Let's just set that 1280, 720. Now the game that we want to make, actually I'll show a little preview of it. I forgot to make a preview before. Here's what it looks like. Yeah, here's what we're going to be making. It's all pixel art. You can see this. It's a little pixel art thing. Anyway, because we're going to be making something pixely, oh wait, I forgot. We also need to set the stretch mode to viewport. That's a whole thing. Godot's really weird there. But we have to do that. So in here, let's just get rid of the search. Down here, stretch mode, viewport. Okay, has everyone done that? 720p won't be pixel perfect, but we're not really going for historical accuracy. It's fine. But next, we're going to be using pixel art. You see, when we set textures, they have finite resolution. So like in 3D, if you zoom into something, it's not going to turn all pixelated. So there's a special type of texture filtering. That's the default, linear, down here. But we do want pixel art, so we need to set it to nearest. So it's down here and rendering textures, nearest, default texture filter, nearest. Rendering textures, nearest. Anyone stuck along the way here? So next, we're going to get started making a basic level. I'm rushing this part so you youngins can still pay attention. You see, we're just going to be making something like this. This is basically as far as we got in the original Unity tutorial we did a few years ago. But yeah, we're just going to create a scene, add a collision object, add a player, and move the player. This might take a while. The rough time estimate is about 25 minutes. I just kind of guessed for these, but it's a bit of effort. So create a new scene, create a 2D scene, rename it level 1, and then save it. So let's get that done. I'll close this here. Create a 2D scene. I will name it, double click this. I'll call it level 1, and then save. Scene, save scene. And now, oh no, we need to save it somewhere. Let's put it in a new scenes folder. Or actually, wait, I have it here. Let's put it in the scenes folder then. level1.tscn. And then just click the save button. And now we have a new scene. Yes? Oh, I don't remember what exactly it stands for, but it's a text-based file format. Yeah, it has like a whole web page here in the Godot documentation. Okay, text scene. Okay, yeah, that's all it is. That's what TSCN stands for. All right, anyway, TSCN file format. So, has everyone created the scene? Everyone's all right. So create the floor. We will be adding a child node, which is with the plus button here, and we will be searching for static body 2D and click the create button. So add a scene, static body 2D. All right, everyone's caught up here? All right. So what's this? A little error, a new universal concept? Well, it's the separation of object and shape. So collision objects and collision shapes are two completely different things. We attach them together because you can use collision shapes for other things too, like a little area to detect where the player is. You can use shapes for all kinds of things, and you can mix and match different types of shapes. So, I don't know, I'm sorry, I didn't make the rules. So give the collision object a collision shape. So add a child node and make that a collision shape 2D. You can right click, add child node, collision shape 2D. All right, anyone stuck? All right, moving on. Another warning, don't panic this time. We just need to tell it what shape we want. You just tell it to get the rectangle. Yeah, up here, this little shape button, select rectangle shape 2D, and then you'll be done with this part. Rectangle shape 2D. It's a little small though. Let's make it big. Let's go with like, okay, maybe this number was a little too big, but I went with like 2,500. Oh, you have to click the rectangle shape 2D. And then it opens up a little menu, a sub-menu. 2000 on the x-axis. If you're familiar with Cartesian coordinates, that's 2000 units this way, 500 units this way. And each unit is 1 pixel, basically. So 5,000, 2,500, 2,500. So now you can see that it's big. And then you can see this blue thing here. What's this blue square? The blue rectangle. The blue rectangle is the default camera view position. So that's how big the camera is going to be, and here's how big the floor is. But now let's give it some color. So we added physics, but the shape is not a visible shape. We need to add a new shape that adds color this time. So we will be adding a color rect, which is a rectangle with color. Color rect. And with that color rect, we are just going to drag it until it approximately matches the collision shape, just because we kind of want to see it. We're going to be deleting this later. This whole platform is just temporary to test the player physics when we set up the player. So this doesn't need to be perfect necessarily, just like generally we want to see where the ground is going to be. Yes. Yeah, it can be a child of either here. As long as we can delete all of it later. Like it's easiest if it's all parented in one thing. But right now we're just setting up this temporary ground so that later it will, so we have this shape with collision. So have there been any issues getting to this point? Can we move on? All right, moving on to the next part. Oh no, there are too many parts. How will we move all of these around? Well, stick the objects together. You see, the children of the static body 2D can be locked in place. And that way you won't accidentally drag and move those when you only want to move like the whole thing. So you select those and click the little lock. And then a little lock should appear. So here are those, and here's the little lock. Yeah, bad audio. So hello everybody on the Discord. Yeah, we've encountered some technical difficulties. I guess this computer was not meant to handle streaming on 2 devices, presenting and running Godot. Yeah, I guess I'm just gonna close it.
You have to redo your editor settings or the actual?
No, I think those saved. They were saved before we did the All right, so any issues so far? Anyone stuck? All right. So moving ahead. Move the floor down. So the blue rectangle outline here is the default camera view if there is no camera node enabled in the current scene. So we will be clicking and dragging this down to the bottom. That way, when we press the preview button, the ground is at the bottom. Whoa. All right, everyone able to move the floor down to the bottom of the blue rectangle? Oh, yeah. And you can also like select from up here, these top buttons if you need. But anyway, the player, we can add a player now, a character body 2D. Used older versions of Godot were a little funnier about their naming schemes. It used to be called like kinematic body 2D, but it's a character body now, which is understandable to an average person instead of having to reverse engineer why they named it that. So character body 2D, we need a 2D one. Make sure that it is not a child of the floor. This is where it's important because the children are considered parts of these objects. We don't want the character body 2D to be part of the floor. We want it to be separate from the floor. All right, anyone stuck? All right, moving on. So next, give the player a collision shape. So this is like the static body earlier, where we need to add a collision shape to it. So instead of instead of a rectangle, we're going to be doing a capsule shape because that's what people usually do for 2D platformers, just because it plays with the slopes more nicely. Slopes are the bane of any indie programmer's existence. So might as well make things easy for ourselves and go with the capsule. Let's see. I will add the capsule here. Capsule shape 2D. As for the capsule shape 2D here, we will set the parameters like this. 5 pixels on the x-axis and 14 on the y. It's not going to matter for like another 100 slides. But yes, it may look small. We're going to make it bigger in a second. All right. Any problems here? All right. So it may look kind of small, like you can zoom in all the way. It's like little tiny dot, but we're gonna make it bigger in a second. Just, give me a second. So as for the player sprite, the image of a character is known as a sprite. We will be adding a sprite 2D and giving it this player texture. Sprite 2D. So moving on, I will show you the texture here in the sprites player. We'll be using the regular player.png. Look at this. It's all pixelated. Look at this guy. He's got a little TV screen head. He's a bit of a rusted little guy. Okay, so now there's a property in Godot that you can do. You can set the scale of something. It'll make it bigger in the editor when it's like not actually bigger outside of there. We'll be setting the scale to 4.0. So on the character body 2D selected, the parent, you see it's the parent here. We will be setting the transform scale to 4. That way it's bigger now. Look how big this is. It was bigger than before, at least. He's still a little guy. But you'll be able to see him in the game now. He's nice and big, scale of 4. What this does by default, because by default everything is 1 pixel per unit in Godot, this just makes it so that it's 4 times. Each pixel gets 4. Wait, each pixel on the texture is 4 display pixels on the screen. All right, any issues this far? Anyone stuck? Something minor, what I would like to do, I don't think I left this in the slides, but the character itself, it's a little offset from the sprite is a little offset from the collision shape. So what I'm going to do is just move it up a few pixels. Just go up to about like, -2. And there it is. -2 pixels. If anyone would like to do that too, just so that it lines up with the ground. And yeah, you can see that there's the player up here in the corner. We haven't added any physics to him yet, but has anyone gotten stuck so far? Any issues? All right, moving forward. So we will attach a script to the character body 2D. Bless you. We will add a script and use the template here, and then save the script in the scripts folder. So you see here, we can attach a script. For some reason, it always saves into the scenes folder. I don't know why it wants you to do that. You just open this up, go back, look for create a scripts folder instead, just to be neat, nice, neat, and orderly. It doesn't really matter too much, but I like to do this anyway. Scripts. I'll just call this, character body 2D, why not? I forgot, template. Character body 2D, basic movement. Make sure you have this selected. This is the template that Godot has for the player. So now you should have something that looks a little bit like this. All right, any issues? Anyone stuck behind here? All right, so basically, congratulations. We are done. We can play the game. Just click the little run current scene button. We have it here. Run current scene. That's the little clapboard, whatever that's called. The default controls are a little weird, though. Let's see. The default controls are like this. Jump is spacebar, left and right are the arrow keys. It's not WAS and D or anything like that. But yeah, here's the script. It uses those, but I will be showing how to manipulate that into getting a proper WASD control scheme. All right, anybody having any issues with anything, or do you have a proper game? Oh, okay. Any issues on the Discord? Anyone on the Discord presentation? I don't know. I will assume everyone is okay on the Discord here. So what I'm going to be doing now is a basic script analysis so you understand what is going on. Let's examine that code now. So we click that button to edit the script here. This will open up the script. Then you can edit it, look at it, do anything you want to it. The script is written in Godot's proprietary scripting language, GDScript, which is very similar to Python in many ways, but some of the keywords are a little different from Python. But syntactically, I don't know, it's almost Python, basically Python. So when it comes to scripting inside a game engine, oh wait, where's the microphone? Where did I leave it at? Here. So when it comes to scripting inside a game engine, oh, that was loud, sorry. It's a little different from like standard programming of a proper executable in and of itself. For those of you who are not familiar with programming, here are some basics of programming. So a variable is an arbitrary value. You can store the number 37, the string of characters skibbity, or a list of values 50, 90, 90, 70, 99, 50, and 14900. And a function is a little packet of code. You like write code inside of it, and then you can call that code or trigger that code from elsewhere. Variables can be passed into them, and the variables passed into them are known as parameters. For an analysis here, this is a variable, var num equals 5. That creates a variable. I guess that's JavaScript syntax there, huh? But then we call this function is5. We defined the function is5 over here. And then an if statement. It'll check if a value matches or is true, and then runs a block of code if it does. If not, the optional else block of code runs. So there's like if number parameter is 5, double equals sign 5, then return true, else return false. So it's like that's how programming works in general. We won't really need to know too much. I have all the code copy and pastable from the slides. And then a comment is a text in the code that the computer knows not to run. They're basically little programmer notes. You like just stick them in there like this. A little hashtag here, octothorpe, #, checks if a number is 5. The computer knows this is not a line of code. Do not do this as like some kind of line of code. But it's left in the file as a little note for programmers. So, scripting inside a game engine. Most programmers are likely familiar with making a game from the ground up. Well, programming inside of an engine is a little bit different. The engine itself has to handle basically everything, but it will check if you have certain functions with specific keywords and will run those as specified. Programming on your own, you call the help of a while loop. In an engine, the while loop calls you. So, you are at the mercy of the engine. You only get to do what the engine says you can. So, scripting inside a game engine. No, I should not. This is bad advice. Why did I do this? Oh yeah, ready. Ready, that was what it was. Ready. Here's the function, func ready. I meant to do that in the slide. I did the wrong one, and there I will be I'm updating the slides live. You can see me updating the slides live. Start. I used the wrong one. The other one, it's complicated what the other one does. But yes. Ready. Runs only once when the object first appears. That was what I meant to do. Process. The engine calls this once per frame. And physics process. The engine calls this once per physics tick, which may or may not be at the same rate as the process. By default, it'll try to target 60 frames per second, but it might not reach that target. And if you're used to Unity, Unity is really weird and only does 50 by default. And you have to like go into the settings and like I don't know, put like 0.16 repeating instead of whatever it has before. It's a whole thing in Unity. I don't like Unity. So back to the script analysis. So we have these variables up here. These are known as constant variables because they say const here, and we cannot modify the value anywhere else because they are const. So that just allows the computer to optimize. So function physics process. If we're not on the floor, this is a Godot function, not on floor. And then we will add to the velocity the current gravity multiplied by delta. Delta is a number that the game engine gives you. It's passed as a parameter here. That's the number of time in seconds since the last frame. So if the computer is really inconsistent, running at like 15 frames per second, then like 30 frames per second, it'll still stay consistent because we just multiply by the amount of time that has happened. So if the input action is pressed, UI accept, it will and is on floor, velocity Y will be jump velocity. And then for the direction, it'll use input.getAxis to try to get like, well, basically it's more for controllers, game controllers, so that if you have like a little control stick, it'll determine how far to the left or how far to the right something is. And then it'll move things accordingly. So that's the direction. It'll be a number between 0 and 1, between 1 and -1. And it could be a decimal if you're using a controller. And then here's the direction. Velocity is direction times speed. Else, velocity of x moves toward 0 really quickly. I don't know why they use move toward here. It doesn't make sense to me. It's just, they basically make it instantly go to 0. So we can turn these into parameters to make Sakurai happy. So we do export var instead of consts. So then we can just modify these values as we want. So let's try that. At export var. And you can save. And now when you select the player, you notice you can adjust the speed and jump velocity. So if I start the game here, and I move the engine over here, here's the game. You can see how fast the player is moving, and then I just adjust the speed. Let's make the player 600. That's double the speed. And now the player is fast. Whoa. Then the jump velocity, you may notice that it's negative. That's because for whatever reason, Godot has Y down. The Y-axis, the bigger the number is on the Y-axis, the lower down you go. So we want to go negative to go up. So here we are. Let's just make this 800. Yeah, let's see what happens. Look at this. Very acrobatic robot guy. Nice. And now, to make Sakurai even more happy, let's add a new parameter. Let's add a gravity multiplier so we can make it so that the gravity is, well, multiplied. We can make the gravity even higher than it is here. We are multiplying the gravity over here. At export var, gravity multiplier. By default, I'm making it 2. Var gravity multiplier equals 2.0. So here, physics process, if not is on floor, multiply this by the gravity multiplier. So now running the game here, we can set the gravity multiplier. Right now it's not modified. Oh wait, yeah, it's 2. It's set to 2. What's this? Unindent. Oh, oops, I accidentally pressed the B when I saved. Pretend I didn't do that. But yeah, the gravity's at 2 now. Look at these physics. Anyone stuck here? Anything? You like the numbers that you have in there? To get out of the script view itself, you click the 2D button on the top. You get back to the editor view and you can add more stuff. Now, you can just mess around with these parameters. Make Sakurai happy. Unlike other engines, Unity, there are no caveats. You can edit while the game is running and it will save. You don't have to memorize your numbers like in Unity. So edit these parameters as much as you want and keep Sakurai happy. Oh yeah, that video. Masahiro Sakurai's YouTube channel. He gives pretty good advice. Gave pretty good advice. He's the guy that made the Kirby and Smash Bros. Series, like the guy in charge of those projects. Spoilers, but the twist ending for his YouTube channel was that he recorded everything that he uploaded for like 2 years in the span of like a month, and has secretly been working on Kirby Air Riders the past few years. So, yeah, I guess watch him if you want more advice on computer, like on game development, how to make things properly. So, anyway, WASD controls. Let's try to manipulate the controls. If you're, well, is everyone up for that now, or still modifying some of those parameter settings? All right, let's move on to the WASD controls. Let's change it so that this is our new control system instead of arrow keys and spacebar. So, what was this input stuff anyway? Input is action pressed. Well, that's something in Godot. That's what Godot lets us access. It's one way Godot wants us to access. Let's start by changing it from UI accept to UI up. Just because that's another thing I happen to know, that's the up arrow key. It contains the up arrow key already. I will stop the game first. There's a little stop button here. Or you could even press the X button to close it. But yeah, change this. UI up. Here it is. But now, what if we want to change these from the arrow keys to WAS and D? Well, you go into project settings and you click the input map tab. Now you can edit these settings. The reason why it's in here is so that it's easier to program, because you could have all sorts of different input systems. You could have a dual sense controller here. Let's see if that, I haven't actually tested if it works on this computer, but I'm just gonna run the game and see if it actually detects the controller. Yeah, the controller works. Yes, okay. Anyway, yeah, it's an abstraction layer. Project settings, inputs. The input map. We will have to show the built-in input actions because it hides it by default. It doesn't really like us editing these, but it's easy to just edit these. Anyway, so UI, we want to filter by name. Well, first let's just go with UI left. So UI left is what it uses in the script here. We want to add a button mapping for that. Let's add a new one. Let's go with the A key. That'll be wet now. Well, we'll just add this to what's already there. So A, and then let's go to the right. We want D. For WASD control, WAS and D. D is right. And then for UI up, we will just put W. So now, if you start up the game, you can use W, A, S, and D to control the game. Revolutionary. You see, we still have, I didn't delete the arrow keys, so I still have the arrow key option, but also W, A, S, and D for accessibility. Or if you just see someone playing and want to mess them up, try to fight the controls. Press the right button on here and the left button on top. So now we've finished that, changed the controls, played it again, and now we can make the player motion smoother if we want to. It's a little more into the programming side of things, but you can see where we are now. It's like really stiff. You like stop pressing the button, you instantly stop on the ground right there. No inertia, no momentum. But we could move it like this. We want to be more like this. You don't necessarily have to, but universal concept, lerp. What is lerp? Lerp, you give it a from, it's linear interpolation. You give it a from value, you give it a to value, and it will then give it a weight of how far to go between them. So you can put like, it will linearly interpolate from one of those values to the other. But the cool thing about it is, you can even make a value lerp from itself to a target. That'll make it like suddenly go really fast toward there and then slow down a little bit and then reach that target. So, yeah. I know anyone more technical here would be like, actually exponential decay is slightly more consistent at low frame rates, but it doesn't matter. This doesn't matter, but if you want to, you can if you're a perfectionist. But we're not going for physical accuracy here. We just need something that works for now. If you want to get into more technical math side of things, you can add an exponential decay function, which I actually have to copy and paste on the next slide if you want that. But yeah, here's the code to copy and paste here if you want to add an acceleration rate and then lerp from velocity x to the direction times speed using the delta times acceleration rate. And then change this from lerping to make the velocity dot x lerp from velocity on the x-axis to 0 and accelerate by the acceleration rate times the delta number of time, and the delta was the number of seconds since the last frame. Since the frame is usually like 60 frames per second, it's going to be like a fraction. But it keeps everything consistent. So as we go here, oh yes, the slide number is on here. If you want to copy and paste the code, I made sure that the slide number is on the corner, so we can still keep that in mind. So we have the acceleration rate, and we will lerp here. We want if moving, then we lerp to that velocity. And if not moving, the velocity equals lerp. Velocity equals lerp. But oops. Okay, so this one we want it to be direction times speed. I accidentally uncopied the other one. Here we go. Direction times speed. And the other one we want to lerp from velocity.x to 0. So this sort of thing you don't really need to do. It makes things feel a little bit nicer when you play it, but I know if you're in a hurry, you really don't need to do this part. But yeah, now we can test it out. Play around with it. Oh, yes. Oh, whoops. What did I? Oh, I did 0. I need to put 0.0. Computers are very picky about this. Yes, what did you need from here?
No, just like, yeah, accept the thing that you were just doing.
Oh, let's yeah. Yeah, you can just go to open up the slides and go to slide number 73 here. But anyway, if you're a perfectionist and want exponential decay because it's slightly more accurate at low frame rates, go for it. Here's the code for that. But yeah. Anyway, we can add a camera next. Add a camera. Add a camera 2D. If the camera is a child of the player, the camera will follow the player. So make sure you add a camera as a child of the player, and then you will have a camera in the game. When you add nodes, make sure to stop it when you add nodes. Camera. Camera 2D. Now we have a camera on the player. Now what if we want to limit this camera? We want it to, oh, oops, I did not make it a child of the player. It's not following the player. Okay, I can follow my own advice. Anyway, here we go. You got a player here. We don't want the camera to go this far below the ground. Let's just limit the Y location so that it can only go down to down here. This is at the Y height, 720. So there's a limit thing here. We want the bottom to only go down to Y at 720. Remember, down is positive in the Y direction in Godot. So positive 720. And now you have this little guy with the proper little physics, all nice and smooth. Everything's all nice and good. All right, so we don't have like all that much time left, so I will be giving you guys a choice. Should we proceed with the user interface and have a title screen, or continue and give our little robot guy some animation? Okay, animate the little guy it is. So we're just gonna keep going ahead here. You're gonna skip ahead. This stuff was like kind of boring anyway. It's just like you create a scene, but this time it's called a control, not a node 2D. And then you add a play button. Then you have to connect it. You have to add the textures to the play button, connect it to a play button script. The script will send, and then the button will send a signal to the script to call a function. And that's the whole thing. And then the transition. Ooh. We're just going to skip that part. So, to animating the player, we'll give the player animation and sound. Look at where we will end up. Here's where we will be in a little bit. Yeah, my estimations were a little bit off, it seems. But yeah, back to the fun part. Give them an animation and sound. So we could still use the sprite 2D, but the textures I set up more easily work through another type of node. So let's just delete the sprite 2D. So change it, or not delete it. Let's change it to an animated sprite 2D. You right click, change type down. So I want to change the type to an animated sprite 2D. And then we will give it a new sprite frames here in the inspector on the right, on the top right of the screen. We will just click the sprite frames and create a new sprite frames. So now we can click new sprite frames and a little window will open on the bottom of the screen. Make sure that window is open for the next part.
It changed the node successfully, but it kept the name as sprite 2D. Is that like?
Yeah, you can keep it like that. It's fine. The name's just, you can even customize the name if you want. We're not really gonna use it too much. So, universal concepts, sprite sheets. Basically, each image is a sprite, and several can be in one image file. So you can see here, I have a little guy. Here's like standing, here's running, and then here is swimming. We didn't get to that part, and we won't get to that part. So we split it up by the engine can split up this big image into smaller images. Whoa. It just makes it easier to handle large amounts of files. And you know, if you have like a detailed animation, you don't have like 100 different image files that you scroll between. That gets annoying. So animating the player, when you click the sprite frames, this window on the bottom should open. This lets you create animations. Double click and rename the animation stand. Because we're just going to make this a standing animation. And then click the funny waffle shaped button to add frames from a sprite sheet. Oh, yes.
The sprite sheet, the grading the sprite frames part, where do you put the
Oh, yes. The sprite frames is just okay, click the animation sub window, sprite frames, create new sprite frames.
put the image?
We haven't gotten to it yet. We're about to get there. Oh, whoops, I left the microphone on the back. You click the little animation frames on the top right here, and then that opens up the window. If you accidentally click off of it or anywhere else, it disappears. So yeah, you have to be careful about that. So sprite sheets here, adding a standing animation. So the files here are in the art sprites player. And then you will find player sprite sheet.png. So if you open that up, the art sprites player player sprite PNG, player sprite sheet dot PNG. We can set the horizontal to 4, vertical to 3, and then select the first 2 frames. These are the standing animations. Oh, this is the number of sprites for the image because it's going to automatically slice it. So horizontal is the number of horizontal. I mean, it is horizontally because there are 4 of these images. So we set up 4, and then for vertical we set up 3 because there are 3 images.
Can it calculate the pixel size itself?
Yeah, just calculate.
So nice.
So you can also just put in the pixel count if you want to do that, but you know it's easier just to put number vertical and horizontal.
Then where do you get to this?
And then when you press the add 2 frames button on the bottom, that adds it into here. You can press the little play button to play back the animation. So I guess I have not been following it on my Godot project here, so I will do that now. So change the sprite 2D, change type to animated sprite 2D. Give it a sprite frames, click the sprite frames. I'll name this stand. And then art, sprites, player sprite sheet. Horizontal 4, vertical 3, only 3 images vertically, and we will add these 2. So now when we play it back, look at this, he's nodding. 5 frames per second, look at that. So now we can try changing the frame rate here, the FPS. It's 5.0 FPS. And then also this little button here, one enabled, it's in blue. It makes the animation loop. Otherwise, the animation will just kind of play and stop right at the end. So make sure that this is in blue, and then he'll just like keep nodding forever. That's the idle animation. Oh yeah, I forgot, I did label that here. This makes it loop. It's enabled by default. If you have an animation that you don't want to loop, then you disable it. But in our case, we want him to keep nodding his head. Everyone caught up here? Everyone done this? Any issues? Okay, moving forward, let's add a running animation and call it run. So go back to add a new animation. I'm skipping through steps now because we're more familiar with it. Add an animation, double click to rename, name it run. Click the waffle, go to the sheets. Oh, and then for this one, we're going to select these. But the thing is, I did not set this up properly. You see how this is, it starts with up in the air. Well, when the animation starts up in the air, that means that when it starts playing, when you land on the ground, you don't touch the ground. So let's just change it. So instead of this being animation frame number 0, I'll just like click it again. Now it's animation number 3. It adds in the order that you clicked them in. So now we like swipe through, unclick this one and re-clicked it. So that's the most recent one. Goes in the order 0, 1, 2, 3. It's it provides better player feedback this way. I'm sorry, I messed up the sprite sheet. But yeah, now we have this animation. We can change the frame rate. I think this one looks nicer at around 8 frames per second. But you can mess around to your heart's content. Make it 8 FPS. Now has everyone added the running animations? All right, moving forward, let's add a jump animation. We'll call it jump, and we'll just add this first frame here. It's just gonna be this. And then swimming animation. We're not gonna get to swimming, so no need for that one. Yeah, for the jumping animation, I will just oops. The animation, I will call it jump. We will need to get these names right when we program it to play the animation at the right point in the code. So I will be writing all these in lowercase like that. The jump is just going to be this frame. And there it is. Run, jump, and stand. That's all we really need for now. So how do we get the code to run this? Well, what we have to do is insert calls in the animation. Insert calls in the script here. So on ready bar. And on ready just means, you know, I mentioned the ready function earlier that runs when you first start. I accidentally put the wrong function there. But yeah, it runs when they first start up, and then never again. At on ready is just a shortcut, so we don't have to type out that whole function if we just want one thing that's on ready. And then the $ here. $ is a special little keyword thing where it'll just grab a child node of the name that you type out next to it. In our case, we left it at the default name sprite 2D. You might have changed the name or changed it to an animated sprite 2D. It'll autofill when you try to fill it in. And then here, it is on floor while like in here, if direction that makes you move. So we'll play a run animation. And else, if not on the floor, or if it is on the floor, then play the stand animation. So we will be adding that now. So here we have the animated sprites. And then if direction, that means that we're moving. Then we will play the run animation. Ah. There we go. And then the copy and paste code is a little iffy. We have to get rid of the spaces. The spaces are a different type of space for some reason. Google Slides does not like me. So if you have an error, you probably just didn't indent. You have to delete the spaces, add back the indents. But yeah, if you're on the floor and moving, then you play the run. If you're on the floor and you're not moving, then you play stand.
Is on floor function, is that built into Godot to just
Yeah.
when it's colliding with something, or is
Yeah.
it specifically the floor? Like if you're against a wall, does it still detect the collision?
Oh, yeah, it's only on the floor. It's like specifically in character body 2D, it has a function that detects if there is a collision shape directly below it. But in these settings, you can change it so that it thinks that the floor is to the right or up above it. But you don't really need to do that, and it's hidden away. Yes?
Yeah, I also saw, when you like autofill is on floor, I also saw like it's on ceiling and stuff like that. So
Oh, good.
there's
Yeah, there's
other ones, I
one.
guess, that are like predefined.
Yeah, there are a lot of predefined functions. It's very handy in Godot like that. You don't need to add a raycaster or anything like that. Nothing fancy like Unity. So yeah, the on ready is equivalent to putting it in the ready function, so we don't have to write type on the ready function. Yeah. $ allows you to grab any of the node's children. So in this case, we just named that child sprite 2D. The editor will give suggestions based on the names of the child nodes. So if you ever need any help there, it'll like suggest, and then you can just select one of the suggestions. But if we test it out now, we're moonwalking. What? The run animation is only in one direction. How do we do this? Well, we have a handy little flip H property to flip horizontally, so we can use that. So down here, it is on after playing the run animation here. How am I going to explain this part easily here? In code, in an if statement, you put these little operators in here, like if a number is greater than this number or less than this number. What this does, what the greater than or less than does, is it's basically a function that turns it into true or false. The true value is, well, when the operator determines that this is true, false is when it's false. So we want it to flip H equals true or false, depending on whether the direction is left. The direction is left when it's less than 0. So that's the logic for how that works. It's just less to type than doing an if statement. You could do an if statement too, but yeah. Anyway, more important here, well, probably not too important, but what I like to do, you only flip back to going facing to the right when you're standing on the ground and not moving. So you go to is on floor and then flip H is false. But it has to be indented inside the if statement. In this one, the if statement does not contain it, so even if you're in the air, it'll point you in the right direction. So, next here, there's no jumping animation. We're just running constantly. It's harder to see in that little GIF/GIF, that GIF file. However you want to say that. I'm not getting into this controversy. But look, we're running and we jump. It's still playing the running animation. Look at that. We're just running. So let's add the jump. In terms of the jumping animation, we will just add here, animate my animated sprites dot play jump. That makes it play the jump animation. We play that when not on the floor or while when you press the up button. That's up here. No. I'll copy this and paste it down here. So now if we test this out, whoa, this guy's all animated correctly. Look at this. Look at this fancy animated little guy. Has everyone done the animation? Any issues? Okay, let's just see what comes next after this. I think it was the child. Oh no, hearing the player. Let's add sound. We have a little jump sound we can do. So you just add a little child node, audio stream player 2D, and give it the resource sounds player jump.wav file. Why is it .wav? Because I didn't care enough to change it. This is this audio. That's all that matters. That was the default export setting. So we will be adding an audio stream player 2D that plays audio. And then sounds player jump. Now in the player script, we will try to trigger that. Oh, I made the sound using a JFXR, by the way. It's just there are all sorts of 8-bit sound generators online. You can use any of them to generate sounds for you, or just use an asset library if you want to use one of those. Or just record something yourself if you want. Anyway, play it. No. Why do I have it in this order? We have to actually add it in first before we add that. I think I put that slide in the wrong spot. Oops. I'll move that. Yeah, play it again goes after this slide. There we go. Okay. So we want it to play. We will add an on ready bar jump sound and set that to the child audio stream player 2D and play it. I will just copy the code I have here. So when jumping, when the input is pressed, jump sound dot play. Now let's see how this works. Here we go, and actually, I'm not sure if this computer actually has audio. I can even hear anything. But on your computers, you have audio. You can hear it. Yeah. The audio settings on this computer are all funny for some reason. I mean, Google Chrome was working earlier, but Firefox was not. And I guess Godot is not either. This computer, this darn little computer. Anyway, I guess we got 10 minutes left, huh? Let's just do like a quick little preview of what else there was in the slides.
We need to upload.
Oh, yeah.
So you want to call it here?
Well, I'll just like quickly look at some future things in the slides. If you want to use the slides as a tutorial, you can, but something you can do in Godot, you can add tiles, automatic tiles, and parallax background. What are tiles? Well, in Mario, you got these things here, the repeated textures. Look at that. Look, it's like
in Mario Maker, you edit the tiles. So we want something as easy to make as Mario Maker. So first, you delete the floor, replace it with this tile map layer, then you add these tiles. Here's the tile set and the tiles. We paint on the physics. You could also select and add physics that way. But I wanted to paint on the physics just to show what that tab does. And these are slopes. Introduction to pain. Just kidding, it's not too bad here. I just made it so you only have to delete the corner point on the physics. Just manually click that, delete the corner point, click that, delete the corner point, click that, delete the corner point, keep going. And yeah. And then there's a way to automatically do it so that you can just paint on all of the tiles like this. You select where the tile, what the tile is. In this case, I made the grass this color here. And then you select where it connects to a grass, connects to a grass, connects to a grass. Select where they connect to each other. And then yeah, it's placing the tiles, things like that. And then it's all nice and well, nice. Other engines, here is Unity tile placement. Very Unity. And then Godot 3.5 I couldn't figure that out in time. And Game Maker, they give you like a little format that you can follow, and you just like fill that out. Basically just fill a thing out. And it's actually quite convenient, huh? But yeah, background, you add a parallax background. Parallax. Here's what parallax is, if you don't know. Things close to you move quickly, things far away move slow. Gives the illusion of depth. So you add a parallax background. That's the background. So then for each layer, you got a parallax layer. In the layer, you can put stuff in it. In our case, we were just going to put one texture, so we put a texture rect. And then we add a second one. The second one is this. Anyway, the pause. Yeah, the Godot has a handy function for pausing. You just like get tree.pause. In the script. Yeah, here it is. Anyway, that's the sort of thing that you'll find on the slides if you ever want to follow those to do more. But we've done the basics of like how to make a moving character and everything, so it's a success. All right, thank you. Let's see. Oh yeah. Any questions? All right, thank you. We end the recording here. Okay. Squeeze up there. And then how do I stop?